imagine. I try to show you a couple books that I'm going to talk about. Let me start sharing. So can you see my screen? I'm trying to have a presentation mode. So can you see the screen?
Yes.
Yep.
Okay. Try to move to the next one. Do you see the next one?
Yes.
Okay, so you see me flipping. Okay, that's good. Okay, unfortunately, I can't really see the chat and all, but please feel free to stop me if you have any question. Please do. Don't be shy. This is a place where we want to learn and ask questions and have fun mostly. So thank you for taking the time and joining me for this afternoon. How many of you attending for the first time? I definitely see familiar faces, so I know that some of you are not the first time, but if you are first time, just raise your hand. I'll have some understanding of how many. Okay, cool. Okay, so welcome. Very glad that you joined. Hopefully you find it interesting. This is the kind of the regular slide that I have every meetup. The first half of the slide, just kind of a welcome slide, what we are trying to achieve in this monthly session. By the way, it's the 15th. It's usually the second Tuesday, but I made a mistake when I created the meetup date, and I didn't want to confuse people, so I left it at the 15th. I usually have it at the second Tuesday of the month. So I think, if I'm not mistaken, this is the third Tuesday of December, unless I'm get it all confused. But just let you know that it's the second Tuesday. It's the last meetup for 2020. 21 meetups since the inception of the group. Kind of kicked off this group almost 2 years ago, and I'll try to be more aggressive next year, getting people to present, people from this group and maybe outside of the group, from the community. I'll try to bring all kinds of big names to present some cool material. However, I still looking at you to help in this upcoming sessions. I'm here to help if you need anything, any question. This is something that I can help you. The second half is the overall agenda. We'll have the GitHub repo of the month, which we'll talk about Conan, which is a C++ package manager, and there is another slide how I used it when I wanted to play with ranges v3. We'll have a lightning talk from Jon Kalb. I'll present him when this is recorded, of course, when we get to the slide. Algorithm, I have many slides about algorithms and various ways to solve, and just to give you a lot of angles of how you can possibly solve an algorithm question. We'll talk about a C++ Stack Overflow question of the month. I cherry-picked 5 C++ quiz, so there is a website that provides C++ quiz. So I picked 5 questions, and we'll go over them. Then book recommendation with a coupon code that I received from Jason Turner. I told him that I'm going to present his book during the meeting, and he gave me a coupon code for you, and I'll present that when we get to this slide. And the the main talk of this meeting would be C++ 11, 14, 17. That's kind of a badge of honor, medal of honor. Take it as like in any way you want. It's you know what? I'll talk about it when I get to it. Any question regarding this? No. Okay. So let me go. The meetup fees are sponsored by Qualcomm Wireless R&D software, which I'm part of. So thank you, Qualcomm, for sponsoring the fees for meetup. Regular slides, we have the Dropbox, we have the Slack channel that is pretty much dormant, people not using it a lot, but it's there. Sometimes I just pick and see if there's anything. We have a YouTube channel where we upload recording. We have a Twitter that I manage, and I have also a Twitter handle that you can follow me. I tweet about C++, software engineering in general, Python, Rust, and Linux, Unix, all the cool stuff that I try kind of to filter and tweet about. Okay. So the GitHub repo of the month is Conan, which is a C++ package manager. I'm basically a big fan of a trend that goes towards having a package manager. Conan is one option. There are other options out there. VC package is another one. But I'm not familiar with VC package. I played with Conan a bit. The group, which is part of JFrog, is JFrog is the same company that has the Artifactory repository, but like it's a product that has kind of has a features to host multiple types of repositories. So Conan, basically part of JFrog, is a C++ package manager. I'm kind of always jealous, being jealous on other languages like Python and Rust and others that they have a good package manager, and I definitely see this thing with Conan as a very good direction in the community. Obviously, not everyone is happy with this. Like everyone might have a different opinion on how things needs to be done, but Conan slowly become the kind of the mainstream in package management. So there is a Conan IO. I'm not gonna show it, but feel free to go to kind of point your browser into conan.io, and it has a lot of it's growing. There's a lot of packages. Each package might have a very kind of supported various platform, various configurations. So the maintainers and authors of a specific package would create that package and push it to Conan IO to distribute that. In your companies, if you have Artifactory installed, Artifactory is another way internally in your company to push packages. And I recently played with it, and I found it something that works reasonably well. And I know that the Conan folks are working on a 2.0 right now. It's a 1.x version, but there is a 2.0 version that is being soon to be deployed, and I'm actually looking forward to see all this improvement. There's a lot of things that they want to streamline and make it a bit easier. In this specific session, I have one slide about like a very simple kind of checklist of how do you use Conan. in your projects. I use it just to get ranges v3 into my local machine and be able to compile and link against the library. Yeah. Any question? No. Okay. So the next one is yeah.
So how do you use Conan if you have you probably have well, you know what I mean about our Docker containers?
Yeah. Yes.
So do you somehow integrate that into the container generation, like the building of the container, or is it related in any way?
Actually, it's a good question. Here's my view, and other can chime in. So usually when you build a container, usually you build it for, let's say, okay, I wouldn't say usually. Let's say you build a container for deployment. So I don't think Conan is suitable for this, and reason for that is Conan is mostly for the development part of the entire cycle, right? So let's say you want to you're writing software and you have dependency in a specific library. So you need the headers, you need the libraries. So you want to compile and link against that. If it's a header only, so it's just the headers. So this is where you just like you do pip install. There is a procedure where you actually running Conan to bring the library with a specific version, and if this library depends on another library, it would bring the whole library in, and and then you can build your software against this library. So you don't need to go and maybe do bring the Debian package or RPM package, depends on which platform you are. No, when you deploy your own software that depends on a library, I don't think Conan is, maybe someone can correct me, but I don't think Conan is the most suitable. So let's take an example of Boost. So Boost, you can have Boost in two different ways, right? You can apt get, let's say you're on Debian type like Ubuntu, you can apt install apt install Boost dev, so you get all the Boost development libraries, headers libraries, or everything into your machine, right? So it's part of the system now, and now you can compile and link against Boost. And in your, let's say in your Docker, when you build the Docker, let's say you have your own Debian package of your own application, and then you also have a run command that install all the dependencies for this. Let's say you install Boost, apt install of Boost, right? Maybe your own, maybe if you have your Debian package depends on Boost, that would bring it. So that would be part of your Docker file. But I don't think you would bring Conan as part of that if you want to deploy. Now, if you ask me about a Docker file that you want to prepare for just development, let's say you have a Docker file for so everyone has the same environment. So that might be an option. I haven't played with it enough to tell you there's all kinds of wrinkles, but it might be an option. But I don't have experience. I didn't try it. I really tried on kind of locally. So if anyone has another thought about that or approach, please chime in. That's so. Gil, did it answer your question?
Yeah, I think so. Thanks.
Yeah. Okay. Okay. I think I need for this to have a good sound. I need to include my computer sound. So 1 second. 1 second. It doesn't let me. It's asking something. So 1 second, okay. Okay, let me try something. You tell me if you hear it. If not, 1 second. I need to share it. So, okay, you can't hear it, right? Me too. So 1 second. Something with my audio. Okay. Can you hear it? Yes, no?
No.
No, okay, but let me try to now share it with audio. Okay, that might work now.
Tonight. I'm not sure
Yes.
when James has scheduled his.
Yes.
We'll find.
Okay, perfect. Okay, so this is Jon Kalb. So Jon Kalb is a well-known person from the community. He's the one organizing C++ Now and CPPCon, and he's a trainer. He also has a podcast with Phil Nash. Phil Nash is also part of the committee, if I'm not mistaken, and working in JetBrain, the folks that actually creating these beautiful ideas that we all use, well, most of us use. So Jon had a CPPCon 2016 in Bellevue, a lightning talk that controversial in my opinion, but I wanted to show you and maybe create a short, just have a short discussion about that. And I'll pause if needed just to explain. So it talks about unsigned, a guideline for better code, and there's I'm already gonna say there's gonna be two camps: people that side with him and people that would not agree. I'm among the group that doesn't agree, but there's a lot of people, good people, that actually agreeing to what he is trying to pitch. So I'll let you decide and go back to the YouTube comments later and take a look at the comments. It's also interesting.
James McNellis and I, he was commenting on Twitter about signed, unsigned, and I took a contrary position, and I said, well, let's fight this out at Lightning Talks at CPPCon, and so you're going to see mine tonight. I'm not sure when James has scheduled his. We'll find that out in the future. So the question is, what does this code do? And because we are pressed for time, I'm going to tell you what it's going to compare a signed and an unsigned integer.
Okay, that's a most kind of known example about a mixture of signed and unsigned. So there are a few rules that comes from C that you just need to remember. There is no other way. I kind of memorized the rules. It's a promotion rules. So generally speaking, when you're talking when you deal with integers expression in C, and C++ is the same, and all the integrals would be promoted to integers. So if you do short plus short, basically the compiler is promoting both of them to integers and create the expression. And then if you need to assign it or anything like so, then it's assigned to whatever type it is. Okay. Now, if you have an unsigned mixed in this whole thing, then instead of signed integer promotion, it's going to promote it to an unsigned. So if you think about this A and B, so definitely -1 is less than 1, right? We should agree on that. But what happened here when you have this expression, A less than B, they are both integrals. By the way, float and double, the two different ranks. Float is the next rank and double is the top rank. But let's ignore floating points for a second. So what happened here is this A and B would be promoted to unsigned. Why? Because if you have signed and unsigned, we actually taking unsigned as the type, because unsigned has higher rank. So what happened here is that -1 would be an unsigned int, and you know what happened to -1, 2 complements when you go to unsigned int, right? It's a very big number. It's all Fs, right? So what happened here is that -1 is not less than 1. -1 would be greater than 1.
And so we have some questions. The first is this going to compile? And yeah, it compiles. But is it perhaps undefined behavior? No, it's not undefined behavior.
No, it's not undefined behavior. The undefined behavior would be with a signed integer overflow on both ends, right? So either max int +1 or min int -1. There is no overflow or wraparound in integers, in signed integers. It's an undefined behavior. The fact that you're getting 2 complements result, that's because that's what the architecture is implementing, but it's undefined behavior in C, and C++ inherit that. Okay, so if you have a sanitizer, if you want to take a look at this at the undefined behavior sanitizer from LLVM, Clang, or GCC, if you take max int, there's a limits, let's say numeric limits of max int, you take the max and you do ++, you'll get undefined behavior triggered from the sanitizer.
But the question is, well, what's it gonna do? What is it gonna print? It's gonna print else. A is not less than B. Well, see, this is the thing. I think even James McNellis would understand that -1 is less than 1. So, so this is kind of the question. Is this what you expected? Now, we all know that C++ programmers are an amazingly good-looking group, but more than that, they're in the top half of the intelligence pool, and you are all at CPP-Con, so you're even higher up. So you probably did expect this, but that's not the question we have to go after. The question is, what will other programmers expect? What will your coworkers expect? Or any random sample of the 4.4 million C++ programmers on the planet. What are they going to expect? And the problem is that most of them are going to be surprised by the unsigned integer promotion rules. So,
okay, out of curiosity, just raise your hand if you knew about this whole promotion rules. From my experience, a lot of people, they're not aware of it. So that's why I'm asking.
So what kind of advice can we give them? What's the guideline that's going to help? Well, we could give them a guideline like that, but I'm not really going to go along with that. So we're not going to do that. So we could do that. That's not really that much better, is it? Okay, well, I believe strongly in the power of positive thinking, but I don't think we're going to be able to write non-trivial applications that never use negative numbers.
By the way, it's not C++. It's C. So So he's speaking on C++, but speaking in quote, but it's actually coming literally from C.
So how about don't do math on unsigned types? Well, this was actually advice that I got from an acknowledged C++ expert when I was asking about this issue and what he thought about it. And this is what he said. He said, this was a private conversation, and he said, well, it's an unsigned type. You don't do math on it. Or we could say don't mix signed and unsigned, because that's the real issue here, right? It's the promotion rules. But the problem is, if you have them in the same application, they're going to get mixed. And so the question is, can you have an application entirely made up of unsigned types? And I think that's back to the same rule of not using negative numbers. So here's my guideline. Here's my recommendation to you, and that is don't use unsigned for quantities. So what does that mean? Does that mean don't use unsigned? I mean, aren't integers quantities? Well, it doesn't really mean that. Treat it like this. Unsigned means it's a bit mask, right? So that means what? That means
by the way, that's the bottom line of his give you a spoiler. That's the bottom line of the whole talk. Use unsigned for bit mask only.
Low-level hardware operations. That means bitwise logical operations. That means you could use them for, say, character sets, because a bit represents a character, right? Maybe you have a data structure that's made up of bits, like a bit map or a big int. Those are all perfectly good reasons to use your bit mask object or your unsigned. But don't use things where you're going to compare magnitudes or where you're going to perform mathematical operations, because these things are going to have unexpected promotion rules. So I'm hearing of course, people are going to be argumentative. I mean, there's a James McNullis in every audience. So people are going to say, wait a minute, this is so descriptive. It tells me, it communicates about my AI. What happens? It's on.
Oh, thank goodness.
It came back. Thank you, James. So people will say, this is an excellent way of documenting my API. And I would say, no, documentation is a good way to communicate something about your API.
So he's saying you need to document. Don't use unsigned for semantic. So let's say you have a quantity, and this quantity cannot be negative. Okay, so I don't know, there is no negative weight, and so they say no. Even though semantically this is correct to use unsigned, don't use unsigned. And a second thing that I would say is that the problem with this approach is that the entire standard library is all, like, not all, there is some size, but I think 99% roughly is all stud size T. Think about all the length of the containers and size of gives size T, like unsigned. So there's, like, the entire standard library is already built on unsigned. Introducing signed, I'll just try it out in your code. You would guarantee to mix right from the first line. You're gonna guarantee to mix signed and unsigned.
Using things like unsigned types to communicate that it would be a bug if it were negative is in fact hiding those bugs. If your code actually returned a negative number because of a bug in your code and it got cast to an unsigned, you would not see that bug. You would be hiding the bug rather than revealing the bug, which is what we would like to see.
I would argue that when we create the math, when we have expression of math, we need to guard against that. Like, we need to catch that even if it's minus, you still need to check. If it's an unsigned, yeah, you get a big number. If it's a signed, you'll get negative. But you need to check anyway that something bad happened, like you're out of bounds of your assumption when you have this expression. At least that's my opinion.
So what about this? Say using unsigned types gives me a greater range of of positive values. I just don't buy it. If you need that extra bit, you're almost certainly going to eventually overrun that extra bit. A sneeze puts you overrun. We don't want that. So just use a larger data type. What about this? The standard library uses unsigned types. Size T is required to be unsigned all over the place. And that's true. You got me. It does. Because they had to have a way that, you know, when you return malloc, you might want to malloc half the size of your address space in a single call, because that's the kind of thing we do all the time. So the standard requires that size T be unsigned. That's an ugly wart. We may fix it in, you know, STD2, but that's not the point. The point is that if you...
Yeah, sure. Fix the whole thing in STD2. Yeah, I want to see that happening.
You're programming, if you can't program in a language with ugly warts, maybe C++ isn't the language you should be programming in. So here are my recommendations. Select the types for the operations they support, not the range of values. Don't use unsigned types in your API. This hides bugs. And don't use unsigned for quantities. Don't use unsigned for quantities. Thank you very much.
By the way, I recommend you to watch Dan Sachs' talk from Code Dive, or I can't remember the exact conference name. And he has a very, very, very good talk about this whole idea of integral promotions and all. And I think I gave presentation in the early days of the meetup. And he doesn't agree. Like he actually has a reference to Jon Kalb, and he doesn't agree. He kind of massages his kind of take away bullets, and I think the important thing is really do not mix between signed and unsigned, because then you're doing something bad. What actually other people do and think when they code? I'm just curious.
I mean, if I'm trying to, if I need, like, if I'm looping over a data structure and I have maybe, like, I need to know the index, then I just honestly use a std size T.
Okay, yeah, me too. And we all know what happened when we if we do int I and we compare it to, let's say, the container.size, immediately. So if you do int I equals 0, so this is an integer, right? It's a signed integer. And then I less than size, like let's say vector, v dot size. So right there, the compiler would say, hey, you're mixing this expression of less than v dot size. You're mixing between these two. So you have two options here. Either you cast it. I don't think that's a good idea to cast the v dot size to an integer, or you say, okay, I'm going to have, so there are a few ways to kind of have that int I. One is have a size t, the other one is have auto equal, let's say 0 u to like the literal u. So one of the argument against this specific example, by the way, from a lot of people is that, oh, you don't need the indexes in many cases, because you can have the range for loops from C++ 11, so you don't need. That's mostly true. Sometimes we do need the index. And C++ 23, I think, would have something from ranges that would be very similar to what we have from Python, the enumerate from Python, that gives you a pair or a tuple that has the index, like a counter, and the element. It's going to be very useful. Okay.
So just to make sure my understanding is correct, the reason this is an issue when you're comparing is because the signed gets converted or promoted to an unsigned.
So the rules are the following. They are really elaborated. So I'm kind of give you the gist of it. If you have a short and a short, or a short of a character, or a character and a character, they're all promoted to an integer. So C said, okay, we promoting everything below integer to an integer. And if you have an integer and an unsigned integer, even a short and an integer, a short and an int, they will be promoted to an unsigned int. So when you have an unsigned in this whole mixture, the unsigned int would be picked. This rank would be picked. And then if you have a negative number in the integer, it's going to be, you know what, let me show you something. I always use this. Okay, 1 second, let me share something. That I just, if you don't remember, just do the following. It's the easiest thing. Okay, let's say you have a let's say a short, and you have, this I would be 1, and I want to return. That I is greater than S. That makes sense, right?
Mm-hmm.
Now you wouldn't see the result, but take a look what happened here. They are both are integers. Okay, now I'm gonna do something like this. I can do. So you see what happened here? So everything is promoted to int, right? We have an int and a short is promoted to int. Now, both of them are int, so the minus is -1. 1 is bigger than -1. Now, what happened here is that the unsigned short is now the -1 is casted. Okay, that's not a good example. Let's do the other one. Okay, so the short is going to be an unsigned int now. Okay, so it's going to be a very big number, and this would be false.
I see.
Okay, so I is unsigned, and this would be unsigned as well, and the whole thing is casted to int because this is what we want to return. And the other way around, so go back to this one. Just wanted to show you the other one. So what happened here is that -1 would be a big number, right? Okay, we can open it in Compiler Explorer. Okay, let's run it. So it returns 0. Okay, so I1 is not greater than -1. Okay, here is gonna return 1. Hopefully, yes. Okay, so you see what happened. Here. Yeah, this is not the best. That's why I want to show the other ones. So this one is what everyone showing, which basically takes the short and make it an unsigned, because both of them are now unsigned. and that's it. Okay.
Yeah. Interesting.
Yeah, I usually, if I can't remember the exact thing, and again, if you do auto, let's say you have a char C1, C2, and you do C1 plus, both of C1 and C2 would be in integers. They are casted to integer and then they are assigned to integer. So there is no such thing expression on characters. They are forwarded always.
I have a question.
Yeah.
Can you hear me?
Yes, yes.
I was wondering why C+ compiler does not promote sign integer to long or signed long instead of unsigned int, because when we are promoting sign integer to unsigned, we are losing some of the range, right? So I was wondering why they didn't decide to promote to a higher capacity type, like long.
Yeah. So I didn't mention that, but long is a higher rank. So I don't remember. I was reading about it like a long time ago. I don't remember what was the rationale behind that. I don't know if it was a they wanted to have like integer was like the neutral length of a specific register back then, and long was a bigger one. I don't really know.
Yeah, probably all the computation is faster on int as a native
Yeah, it's
type.
like a native one. Yeah, and long is a higher one. So if I have an integer or short and all, they would be casted to long. But yeah, the natural one, everything that is below int would be an int, not long, and then you have an integer, and an unsigned would break the tie. If you have a signed and unsigned is breaking the tie of the same rank. Then long, same deal with unsigned, and then float and double, like double precision. One of the things that I wanted to show, and I have it in the slide, is C++ has these utility functions that allows you to do some safer comparison. So this is actually very cool because it is actually doing the right thing for you when you're mixing signed and unsigned. I'm not using 20 in my day job. I think 20 was got the last stamp of the ISO today, if I'm not mistaken. I've seen that announcement happening today. So, but lots of compilers already implementing. So there is this utility functions part of the library, and this stud, compare equal, not equal, and all. They are safer than having comparison like this. Okay, and this is the same thing where an integer -3 would be promoted to an unsigned, and these things would look very like 7. It's false that 7 is greater than -3. All this stuff, but it's not going to happen here. So that's cool. So something that we can keep in mind. All this nice addition to the 20 standard. Okay, let's continue. Second, let me do the presentation mode. So the nth element. So the nth element is kind of a problem from Geeks for Geeks kind of magazine, and the idea is that given a vector, let's say x n numbers, give me the like k number, give me the nth element while we don't count the elements that have the digit 9 in them. So let's say we had 1 all the way to, I don't know, 12 or whatever, and give me the 10th element without the 9. So 1, 2, 3, 4 all the way. So the 10th element would be 11th. Okay, so 1, 2, 3, 4, 5, 6, 7, 9, 10. So how to do that? I have a lot of code. I'll try to explain it as much as I can. Okay. By the way, don't confuse it with the nth, the stud nth element. There is a standard library algorithm, nth element, that provides you the nth element. So let's say you have a vector, it's unsorted. When you say, give me the nth element, let's say in this range, give me the nth element 7. So it would give you the element in the 7th position, as if the whole vector was sorted. So if you think about it, it's like when you do when you sort, you do quick sort, you'll have so nth element is the building block of quick sort, where you actually start putting the elements in their place. So the nth element is one of the building blocks of. So don't confuse it with that. That's like, give me the nth element that doesn't in a sequence that doesn't have 9. Okay, so I'll have all kinds of kind of a helper statements and functions. So let's say I have 100 elements from 1 all the way to 100. I want the 10th element, and take a look how I write the code. Again, you can go and do whatever you like in your code, but I'm using an unsigned everywhere, so I'm guaranteed not to mix anything. I'm not using anything. So unsigned 100, and the nth element is 10, and I'm using order, and I'm using constant expression. I'll talk about constant expression in the next section. Then I have a vector of n, so n elements, so I have a capacity of n, and then I'm using C++17 iota, where I provide a range, and I want to fill the range with numbers from 1. So I already have a capacity of 100, so it's going to just fill the vector with 1, 2, 3, 4, 5. So iota is a very nice way to kind of have that done. Now I have a helper lambda. A lambda is basically just a callable object. Syntax looks very strange. I'm using ordo because I don't care and don't know the actual type of the lambda. So the lambda is just a function. It's a callable object. It's a function. It has a body. So this is the body of the function, and it has a single parameter. So think about the function. Just ignore the brackets here. So given a number, I'm gonna return true if I can't find 9. Now this is an awkward way to do that. In C++23, a lot of containers, including string, would have a dot contains function, just like in Rust. I'll talk about Rust it's a C++ session, but I have actually a slide on Rust. And then a print, it's a lambda where I can pass the lambda to a for each. A for each is just a for loop from a beginning of the vector to the end of the vector, and I'm going to call print function every element. So I'm going to just have all the from 1 all the way to 100. So just it's a helper functions. If you want to take a look at the code, you have a way just to play with it. So it doesn't do anything useful right now. We have the lambda that we're going to use. We have the print function if you want to print, and that's it. So we start with the simple approach using a plain loop. So what I'm going to do, again, I'm going to use this has9 reference, which would give me return true if it has 9, false if the element doesn't have 9. So I'm using a C++11 for loop, range for loop. I have a vector here. There is a colon here, not semicolon, just a colon. And I'm taking the element by value const. So I'll get 1, 2, 3, and for every element I'm asking is this element, does this element contain 9? If it does, I'm just continuing. If I'm hitting the nth element, I'm breaking. So I'm just counting how many elements I have until I hit the nth element, and I'm skipping everything that has 9, and that's it. I'm done. I have the counter here. I can access it, and I'm done. Very efficient. The generated code is going to be very, very efficient. Not super complex super complicated to understand what's happening there in this loop. Hopefully you agree. A second approach is to use remove if. Now, it's not going to be as efficient as the for loop. Reason being that I'm actually providing the entire range, and I'm taking everything that has 9 and pushing it to the end. Okay, so I'll end up, so the remove if would give me an iterator to the element past the element after the last element of the new range. Okay, so if I have, let's say, 1, 2, 3 all the way to 10, after remove if, I would have 1, 2, 3, and then 8, 10, and 9. And just remember that in begin and end iterator, the end always points to the item past the last item. So hopefully it makes sense. So it would point to the item after the 10. So it's going to point to the 9 that was pushed to the end. So now I can print, or I can actually take the nth element, since this is a zero-based. You need to do the math in your head, and you see that I need -1 here. Again, it's not super efficient, and the reason for that is if I have a very big array, I need to go. This remove if would go and traverse the entire array, and then let's say I just don't want let's say it's an array of 100 elements. I need to do it for the entire 100 elements, and then I just need to look at the 10th element. I kind of wasting cycles, so it's doable, but not super efficient as opposed to this one. This one is actually stopping right when we're done, so we don't care about the other stuff. We're just skipping the 9th and just counting. This third approach is using ranges v3. Now, ranges v3 is all about lazy evaluation, which means you create these expressions and you are capable of, instead of completing the entire expression and then piping it to the next expression, you are doing it in, I don't know how, but like a log step or kind of a pipeline. I don't know what the best word to put that, but basically it's a functional programming lazy evaluation. Now, when I needed to play with it, I wanted to use ranges v3. The reason I'm not using C++20 ranges, so ranges v3 is the open source library written by Eric Nibbler from Facebook, and it's the library that was kind of the basic architecture to the actual kind of the inspiration to the actual proposal that went into C++20. And 23 would add more stuff from Regis v3, so more stuff would be coming. So Regis v3 is much more richer, has more features compared to what went to the standard so far. So I wanted to use Regis v3, and the easiest thing for me to do, believe it or not, was to use Conan. Now there's some steps that you need to do. They're not very complicated. It's not complex, but they need to be done. I know that in future Conan versions like 2.x that I mentioned will have it even easier. But the idea is the following. You create a virtual environment and you activate it. Now, don't be shy using virtual environment in your projects, in your C++ projects. There's a lot of utilities that can be used in conjunction with your C++ project. Conan is a good example. You pip install Conan in your virtual environment. Then you edit your CMake to include a Conan .cmake file. And I don't know if you can see, but I have an example here. So there are two lines that you need to include. For ranges, so you're gonna have a Conan file.py code generated, and I'll explain. And then there is a place in this. It's just a Python file. You need to add range v3 and the version. So this is the library version, and there's also where you can add more stuff. But basically, this will be enough to bring. In your build directory, you run Conan install and the path to your source. For example, .. if you have your build just right under. Now everything is primed and you can use Conan. The CMake would find it for you. You can have Conan libs, or in some library you can have the specific library, but I've been lazy in just using Conan _libs to get everything that Conan is finding for me in the target link libraries. So just kind of a short example of how to use that, and please ping me if you have any question regarding this. For this example, I'm using a booklet from Regis v3 that I highly recommend you to pick up. Either it has two options, either PDF or soft cover. It's about 72 pages, and very nicely organized and illustrated. I found it very, very useful for my learning of Ranges library. And again, I'm not using Ranges library in my day today. I mean, mostly in 11 to 17. But looking at the future, C+20 would be something that we probably use in our day job. Like probably all of us, at some point we'll use C+20. So Ranges is really, once you get used to Ranges, it's really, really nice and easy to use. Okay, so I actually have two options, two Ranges v3 options that I wanted to play with. The one here and one here. So let's take a look at what kind. And this is really kind of on the advanced part of the C++. I would say the entire material of C++ as of today. Ranges are kind of on the more advanced part of it. So remember IOTA? So IOTA in Ranges would give you a lazy evaluation range that you can start. If you know what Python generator is, it's like Python generator. So you can do the same with Python generator. When you can say, okay, give me another one, give me another one. It's going to yield another one, yield another one. So that's very similar to this. And we start with one. Then I take, I'm doing it in steps. You don't have to. I just wanted to have like just to explain. I kind of broke it to 3 steps that you can have all of this in one line. Okay, so So I'm taking this range of integers, rint, and I'm piping it into ranges, views. So ranges, there's actions and there's views. Actions are actually making some modifications, and views are just kind of a lazy evaluation, a view to a specific range. And I'm using a remove if has 9. Now, this one, as opposed to the other remove if that I mentioned, this one is a lazy remove if. So what does it mean? Every time you introduce, so you go one by one. Every time you introduce something, it checks the predicate and see if it, and then it wouldn't, if it has 9, the digit 9, it wouldn't pass it to the next element in the pipeline. Hopefully it makes sense. Just ask question if it doesn't. So I have this range view of known ninth. So if I take it and I print this known ninth, I would print 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, and so on and so forth. I wouldn't, like, I can print forever, right? Iota, there's no end. So I can print until I want to stop, and I'm not gonna have 9s, but it's a lazy evaluation, which is super cool. Okay, now what I want is a stride of the 10th element. Now I need -1 because of the zero base. So I need a stride of nth element -1. If you play with it, I need to play with it in order to understand that it actually I need -1. So stride would give you 1, and then 11, and then the next one, and so on and so forth. So it's strides of 9. So 1, 11, and so I don't have 9 inside. So since it gives it, the stride starts with 1 because that's the first number. The stride starts with the first number and then start giving you the strides. I need to drop the first one. So now, this is drop the first element and then take just one element. So if I have 1, 11, and so on and so forth, I'm dropping 1 and I'm taking the 11th, and this is what it's going to be printed. Now, how I ended up with this, I just read all kinds of the documentation and this booklet that I mentioned here, and try to assemble something that works. Now, it's definitely, in terms of complexity, it's doing the right thing. It's not going to be complicated. Like, it's not going to have an O end of the entire, let's say I have 100 elements, not going to do that. But if the question is it easy to understand? It depends on if you know enough about ranges or not. Here's another ranges v3, and here I just use Compiler Explorer, and I have a link in the meeting notes, so you can take a look at that. In Compiler Explorer, godbolt.org, you can have a ranges, and this is how you include it. Okay, let's take a look how it looks like. So the iota is the same, the has9 is the same. Remove if also is the same. So now I have a known ninth kind of stream. I pipe it through, take exactly 10, which is basically 10 is my nth element. I could have n here. I just put 10, and take the last one. So what would happen is take exactly 10 would be 1, 2, 3, all the way to 11 without the 9, and I want to take the last n element. And here I want to take the last one element. So if I had the last 2 elements, it would be 10, 11. If I want to have the last 3 elements, it would be 8, 10, 11. But I want to have only the last element, which is 1. Which this is why I put 1, and it's going to have the nth element, which is 11. So maybe there are other ways to solve that. I try to kind of come up with a couple of examples so you have some maybe first or initial exposure to the ranges B3. By the way, the nth element is a range of one element. If you want to so if I do stud C out of nth, this one, it would be, you see brackets, and inside it's going to have the number 11 because you get a range, right? If you want to have the actual extract the actual element, you can have the nth, this variable that begin. It would give you an iterator to this first element in the range, and then if you dereference this that begin, you get the number 11. That's it. So it's nth element is just a range that has an overloaded stream operator that has this nice printout with the brackets. Okay, now you could use a lambda, which makes it very ugly, and it's kind of an anti-pattern that most people would say. So just ignore the lambda here for a second. Let's take a look at the let's see, option laser. Okay, so take a look at the so get nth element. I'm taking a vector. Has 9 is the factor. It's the lambda that n, and nth element would be, let's say, 10. I want the 10th element, so so the result would be 11. So what is get nth element? I just made it a template just for fun. At least the function, it's easier for me to have it a template because I don't know what the type of the lambda is. So I have a counter that I pass it to the internal lambda. It's a predicate counter, and what I really do, I take this lambda here and I shove it into this all off. Now all off would do a short circuit if the predicate here returned false. Okay, so basically what I want to do is I want to take a look at all the numbers, count. It's basically very similar to the loop that I showed you before, and stop when the counter is the nth element, and return false, and all off when it sees false, it would stop. So yeah, it works, but I just want to show you that if you're thinking about doing lambda, it might look like this. So it's a lambda that takes a lambda and use it here. This is where it's using the lambda, but and you need a mutable because you have a counter here that you need to kind of plus. I might not need the mutable. I need to take a look again because it's a reference, and I don't think we need the reference. We need mutable for a reference, but I think initially I wanted mutable because I thought I'm going to change that. But anyway, I wouldn't suggest writing this, although it's efficient and all. I looked at the code generated; it's pretty efficient and it looks nice. Okay, the last thing, although it's a C++ session, I actually wanted to see how can I do it with Rust and how easy would it be to do it with Rust. So let's say I have a capacity of 100 elements, and I want the 10th element, so I want 11 to be printed at the end. So I'm creating a vector, and there are multiple ways to create a vector. I decided to create it this way, where I have one ... equal capacity. The equal capacity just makes it inclusive. So I'm going to have 1 all the way to 100. And that provide me a vector type, okay? And the whole thing is in these 3 lines. By the way, there is something called advent of code. I don't know if I pronounced the name correctly, where it's once a year, I think. There's like maybe a week or couple weeks of every day there is a question submitted and people try to solve it. I see in Twitter that most of the people using Rust because it's so easy to write algorithms, to solve it with algorithms using Rust. So the way it works is the following: you have the vector and you create an iterator. So that iterator will create an iterator, and then filter. I don't want the digit that contains 9. Okay, so X is basically the parameter to the closure. So so I have a filter. Again, it's kind of a lazy evaluation, and then give me the nth element. I really like this nth element. I actually was looking for something similar in ranges v3. I couldn't find anything. I looked very hard, but I couldn't find. So again, it's a 0 base, so I needed to have this -1. So everything that does not contain 9 would be passed, and then the dot nth would give me the result, and the result is an option. If you know Rust, it's an option, and then just putting unwrap would just either give me, if there's anything there, what we call sum, it's gonna give me something. Otherwise, it's gonna do abort, what we call panic in Rust. Just an anecdote. You don't really need to do much about it. I just wanted to show you this angle as well. Okay, the C++ Stack Overflow of the month. So it's actually something that I realized when I explained something sometime back a few weeks ago. So take a look at this class. It has a private structure type var, and it has a public function that returns it. It returns bar. The interesting part is that how can you actually access? So if you do auto b and you have f.buzz, auto is full colon bar, because buzz is just returning bar, right? But you can't explicitly say, okay, food colon bar b. You can have that, so you can have auto. So there is a Stack Overflow that explain, and it's the same deal. They have an example of templates. I want to show it again here, but the name, only the name of the type is inaccessible. Like the name of the type is so you can't really like explicitly say, okay, I want full colon, but the type itself is usable. So this is where auto helps here, which is really cool. So C++ quiz. Let's do a few of them. Let's do a couple of them because it's already 7:20 and I haven't started the main thing. One second. Okay. Okay, so I got into C++ standard. What is the output of this program? So we have A and B. A is the all struct, so everything everything here is public, and we have B inheriting from A, and we have an operator, a stream operator that takes an output stream A by ref, and that's just called a.put, and we can see that there's a virtual here. There's a virtual here, so the same signature, so it's just the inheritance, and there's a override. There's no, like C++17 you can write override here, but it didn't happen. So okay, so we instantiate B and we do std_cout B. What do you think would happen? And this is a easy difficulty. So the options are: there is some output, compilation error, unspecified, compilation defined, or undefined. So since it's a virtual function and we pass to the base, the virtual function would kick in as far as I remember. I don't know if I remember it correctly, but I'll try B. And yeah, it's basically just it's a polymorphic behavior of operator, stream operator, because you can do it in a different way. So okay, so the next one is okay. We have this again. This is a C++ 17 medium difficulty. So we have F, which is in global space. We have a template B that has also F and prints 2. We had D that inherit from B, and it depends on T. So B depends on T, okay? And we have a G that calls to F. We instantiate D with integer, and we call G with D. So the question is, obviously, which F would be invoked? So we have the global namespace F, and we have the one that we inherit. So again, what is it, compilation error, or there is an output? Is it undefined or implementation defined or unspecified? Now, the thing is, this is a very subtle thing in and very error prone in templates. Templates has like a couple of phases where being instantiated. The lookup is happening in the first phase. Now, what happens is the following. During the first phase, when this one is instantiated, the functions that comes from a base class that depends on the template parameter. This is the key. It depends on the template parameter. They are not the functions that come from BT are not not considered in the search when you have an unqualified. So this is an unqualified F, right? So what happened is that the compiler in that phase is completely blind to what happens in BF. There is no BF for now, so it's gonna be 1. Now the question is, and you can read here later. The question is, how do you fix that? Any guess? There are at least a couple of ways that I'm familiar to fix it. How do you make the compiler aware that there is something here that you want actually to call F from here? Let's say that's the intention of the author, to call F from B. So this error would be what I usually do. Okay, and that actually works well. Okay, so let's give up on the other C++ quiz questions because we are kind of very behind. Okay, book recommendation, C++ best practices by Jason Turner. It's a very nice. It's short, kind of a short couple hours, and you go over that very quickly. Maybe not couple hours, maybe a bit more, but it's kind of 45 simple best practices, about 120 pages, and you'll see things about don't use new, know what containers to use, don't use std_bind or std function, how to use package managers, how to use build generators like CMake, how to improve your build time, use null pointer, use scoped enum, don't use global state, use no discard as much as possible, use explicit as much as possible, don't copy and paste code, and so on and so forth. Each best practice is about a page or two, so it's very easy to follow and go over. It's suitable for every level, so I would definitely recommend you to take a look at that. And there is they spelled San Diego wrong, but so I asked Jason to fix it, and so both of them, the San Diego with the typo and none, are kind of both of them would work. Can't remember how much of the coupon is, so can't remember. So you can try it out. It's going to be part of the slide, so you can just click on it, and the coupon is enabled since yesterday all the way to the 18th, I think. So you have a few days to use it, and it's kind of cheap. Okay, I'm gonna not mention this because I have half an hour and I really want to go over the other slide deck that I have. Give me a sec. Presentation mode. Okay. So few months ago, maybe 6 months ago, a co-worker came to me and say, it's a good friend of mine, and say, hey Kobe, I haven't done C++ for a long time. I don't even know what's up there. Like I need like a very simple way to kind of skim or traverse or just to see a high level of what are the tools in my toolbox that I can use when I writing in modern C++. And I started writing this slide deck back in July, I think, and wrote few slides and then abandoned it for a few months and decided to present that in this upcoming in December today. And what I did is basically I decided to take each feature, and I don't think we'll finish all the slide deck. That's fine. That will be part one. We'll talk about part two next time. So I actually took every feature, like the main feature that I think would be important for you to know, and I gave, I kind of assigned badges to each of them. And I created this set of badges, which is readability, safety, maintainability, productivity and usability, speed, library authors, and portability. And it's really my opinion, so feel free to ask questions and hey, why you don't think it deserves a safety badge. It's kind of an open discussion, so feel free to stop me anytime and ask questions, and because it's going to be very high level. It's really targeting beginners, so if you're more seasoned in C++, you might be a bit bored in the next 30 minutes or so, but there's all, I hope there's going to be good discussions coming from that. Okay, the first one is using directive instead of typedef, and I just picked one specific, I kind of highlighted one specific example. So typedef of pointer to a function. So the left side, 1 second, has this pointer. It's a typedef to a function that has two parameter, integer and character, and it returns void. Doesn't return a value, basically return void. The using keyword that introduced in C++ 11 allows us to have kind of separation between the left side of the equal sign and the right side of the equal, and it's much more readable, I think, you can tell me, looking at this syntax versus this syntax. So readability is definitely something that I would provide as a badge, and I think lib authors would make a lot of use of this feature when they need to have an alias like a type def to their maybe class types, or maybe something inside the class type, all kinds of maybe constant and so on and so forth. Not constant, sorry, types inside the specific type, like a nested type and all. I think this would be a very useful and handy feature for many lib authors, as well as just the regular application writers. Just improve and increase readability. Again, stop me if you have any question. This is not a C++ 11 or a modern kind of feature. I just found it important enough to mention as a feature that I encourage people to use, and this is const member functions. And in general, I would suggest we just have const everywhere. It has multiple reasons. One is readability. You can make sense of the code if you know that there's a lot of things in this snippet of code that you read that they are immutable. So you just focus on things that can change and not things that, and then you know that this value would never change, and if you have more and more values that are immutable, it's easier to reason about code when reading. So const function is basically a way to when you enter to a const function, what we call this is const, which means that the data members are as if a const was written for them. So it's like a const int x underscore was written. And it's really useful because if you have a const object and you want to call a get x, and you don't have a const version, this would fail to compile. So once you start using const in your code, you need to start putting it in a lot of places, because then if you're missing places, you wouldn't be able to compile. So here's an example of this is happening in compile time, not in runtime. This dispatching to the right function, since it's a const function, it's a const type, foo, it's going to be invoking the const function. So maintainability and safety is what I kind of assigned as badges to this important feature. Okay, explicit constructors. This is also not new, but it is a new for conversion operators. So conversion operators can be explicit. It's avoiding accidental and implicit conversion, which is always bad. So it's safer. It provides you speed, and the reason for speed is that when you have an implicit conversion, you might create a temporary object in your in the code, like in the runtime code. So by avoiding implicit conversion, you actually can have you can increase your speed in all kinds of code paths that accidentally creating temporaries, because a specific, and I have an example here, that if foo was not having an explicit, it is, I can actually take take a look at this, do something. I pass 7, it would fail because of the explicit. But if there was no explicit, this do something 7. So foo has a constructor that accepts an integer. So constructors, they are not only constructing an object, they are also acting as a conversion operator. So the compiler would go out of its way to create an object for you if it's possible. So 7 would be converted to a foo, so you get a temporary, and do something would actually hold a temporary. Maybe you don't want to do that. So having an explicit would fail to compile. And same deal for an explicit operator. It would fail to compile. So foo2, for example, cannot be implicitly assigned to a Boolean. You need to explicitly cast it in order to get that done. Sometimes you want to do that. It really helps in maintaining your future code base. By default, a lot of people and a lot of trainers saying have explicit by default, and we wish that everything was explicit by default, but it wasn't. Override. So override is one of the features that I consider to be a safe and predictable one, and helps in maintaining the code. Reason for that is the following. Look, if you have a base class with virtual f and you derive, you don't need to have a virtual here. You can have override. You should have override, and you can also have final. You can say no one can override it. Maybe another derived class that derives from derive cannot have. So this is another feature. But the reason override is so important is because we are telling the compiler, look, my intention here is to override f. Now, if someone in the future comes and add a parameter or change void to something else, returning something else, this code would fail to compile because the signature is not the same anymore. And the compiler would say, hey, look, you wanted to override f, but f, there is no f in the base class with the same signature, so it would fail. So if someone comes and says, oh, I actually need another, and this looks simple, but think about code base that the base class looks huge and the derived looks, and it can miss the details. Override is a defense mechanism to kind of make sure we are doing something that is sane. You can also have overriding operators, overload operator, and destructors. Yeah, you need to add them as well. Final class and final functions. Long time ago, I read somewhere that in some cases, final actually make your code faster. I haven't put that as speed, but I couldn't find the reference. But in some specific cases, the compiler can do some optimization and have that make things faster. The important thing is communicating intention. So it's very important for maintenance, and it's very important for readability. Having a final class or a final function communicate to the reader that, look, I did not design this class to be inherited from. It's not a base class because XYZ. So for base class to work properly, there are a few things that needs to happen. There are a few rules that you want to follow, like best practices. If you don't follow it, you make a mess in the future when you need to maintain the code. So it's important to have that. Of course, if you are working in some code base and you see final, you can always like go and delete it. Don't do that because the author had this final for a reason, and you breaking assumptions, and you might have some issues in the future. So don't. I have it as a default, unless I want to have this class as a base class. Okay, auto. Auto is a huge subject. I'm not like, this is really just a taste of it. It's a compile time type inference. I have some examples here, but it's a huge subject. There is this AAA, like AAA, AAA, like almost always auto that some people advocate for. And as long as the code is readable, yeah, go ahead and use it. It allows you to write code that is easier to maintain in some form or shape, because you don't need to, if you change the type, you don't need to go and change the type all over. Let's say the type is just a pass-through type or something like that. So you don't need to go and change the type everywhere. Here I would be infer as int. Here I'm using a string literal, so it's going to be stud string. This is going to be a stud string view. It's C++ 17. This is going to be a chrono duration. This is going to be a lambda. And here I have an example of a function with return type, trailing return type that returns auto. Yeah, you can do it as well. Safety speed, because you in some cases, which I'm not showing here, you having a specific type specified, and then you will do equal something, and it's not the same type on the right side and the left side of the equal sign. And what happened is there is a conversion happening, and again, maybe some temporary would be created and so on and so forth. So by having auto, you're getting the exact type that you wanted. So it increased the speed. It really increased productivity, usability, helps with maintenance in the future. And it's much safer in many cases, just like I had with the speed. It's much safer to use it in some cases where you don't know the actual type. Okay, null pointer and null pointer t. So null pointer t is the type, and null pointer is the actual value. Long time ago, we used null or zero and all. Now we have a better way to say, I'm actually want a null pointer. So with null, which was pound defined, or with zero, you can get ambiguity, because zero can be convertible to int, to a pointer to an int, or to a boolean. With a null pointer, there is no ambiguity. You're gonna only treat null pointer with pointers. It cannot happen with anything. It cannot be convertible to any other type. So grateful lib authors, grateful productivity, portability. It's actually getting a lot of badges for me. Safety, readability, easy to maintain, no brainer here. If you are in a code base that has access to C++ 11 and beyond, basically more than C++, using null pointer is a must. You definitely don't want to use null or zeros.
Quick question. I believe if you're having pure virtual functions, you have to define them as using the equal to zero. Could you define them using equal null pointer, or does that?
No. I don't think it's going to compile. No. The equal to zero for pure virtual function are very, very specific syntax. Okay. Yeah. Range-based for loop. This is a C++ 11 I'm using here something that called compile time argument deduction, so I'm not providing the integer in the vector, so it is a vector template. And range-based for loop are very, very neat. They are very easy to use. If you don't need the index itself, you just need to iterate. There is no reason for using the regular for loop when you have a range, let's say a container or anything like this. I'm using auto because I don't want to specify what it is. Maybe vector tomorrow will be a double. So I don't. Why would I use the specific type? It's readable as is. I'm just wanna see out. So keep auto, and here I could even do const auto, just for shorter slide. I just remove the auto, but yeah, you can have auto. It's gonna be less of an error prone, so it's much safer. No issues with dealing with unsigned and signed complexity and this whole mixture. As I mentioned, C++23 would have enumerate for ranges. It's easier to maintain, easier to reason about all this int I and I less than something, I plus plus I or I plus plus, all this post increment, pre increment, all of this stuff going to be not really needed and stay too much of a code, and this is much shorter in there. So definitely range-based for loop is a feature that you want to use.
In that line that you're defining the vector, what if these numbers are like out of range for int? Does the compiler take that and makes a vector of long or not?
So if it's more than an int, so I can try it out to see what the compiler, and it might depend on the compiler warnings, but it might cast it to an int. Let's say it's beyond, so it's gonna be negative. Like a number, as long as it's represented in an int, it's gonna be like if it's gonna, let me think about if you have like unsigned long, let's say 4 would be unsigned long, then it's not gonna compile because you have int and unsigned long. All of them needs to be the same type. But if you have a number, I think the compiler might take it as is. I don't know. I can try. Let's say a number that is beyond an int 32. I don't know what would happen. Can take a look and see if it's gonna be just casted. Maybe just like if let's say you have a big number that can be represented in uint64, but not in not in like in int 64, not in int 32. Maybe the compiler would just cast it, like truncate it, I would say. I don't know. But if you specify the actual type, like for ULL, then what you would have is a compile time error because you said I want int, and one of them is not an integer.
Nice. Thanks.
And we can try it out. By the way, actually after the meetup, after dinner, I'll try something. See just what happened with these two options. Never tried it. Okay, enum class, also known as the strongly typed enum, is encouraged to use for all kinds of mask and things like that. I still use enum because of enum class is not convertible to integer, so they are strongly typed, right? They are not implicitly convertible. So red in the second one is not convertible to 0, and blue is not convertible to 1, but the first one is yes, like the C version is yes. So the the first one, the C approach, had an issue. The red and blue were part of the enclosing scope. The color didn't have its own scope. So if I have another enum in the same scope, it would be an issue. It doesn't provide a new scope, but the enum class has a new scope. And it's not convertible to an integer. You can have it in the switch case, no issues with this. You always need, if you want to refer to red in the second one, you need to have color, : red. You need to qualify with the scope. There is a way to take a look at the underlying type to actually convert it to an integer, like static cast it with the underlying type. So take a look at underlying type if you need to. Use it unless you really need to have it implicitly convertible to an integer, and doing all kinds of static cast makes the code ugly, which makes it ugly if you really need. But if you just need enums and you don't need that to be convertible to integers in any case, this is a good feature to use. Any question? Okay. Okay, std initializer list. It's a new thing from C++ 11. It's kind of a built-in container with a fixed size. So it's being used a lot in a lot of containers, vector and list and map. They have at least one constructor that takes initializer list. And I can actually I can iterate over initializer list with the range for loop, just like I had it here. Again, it's useful for initializing something that is known in compile time. It's kind of a sequence. We didn't have this before. We need to create an array, like an artificial array, and have it. Now it's kind of it's a built-in. It has a begin and end. So it's really easy to use. Regarding the safety, I didn't want to put safety because pre-11 there was some fiasco and confusion about mixing auto with a single number in a initializer list. And in my notes, in my slide notes, you can see an example of what happened. It doesn't matter right now, but just, I didn't put safety because it actually there was issues with pre-17 and it was fixed in 17, but still all kinds of confusion that people have. There's a lot of issues with initializer list sometimes in a constructor because initializer list is preferred if you have two functions, one with initializer list and one without, like overloading functions, and they have a similar signature that can be, it looks like an ambiguity. There's no ambiguity. The initializer list takes precedent. Okay, no except. So there was all kinds of throw, specify, and all that was deprecated in C++ 11 and above. And instead we have no except. There's more stuff that you can do with no except. I just provided a very simple one. No except basically tell the compiler to the client of this function, look, I would never emit an exception from this function. So if I'm calling swap, I know the compiler would guarantee for me there is no exception. What happens if you emit something? You said I'm no except, but you throw. You're gonna create a function. You would call std terminate, and you'll abort. Why? Because you had a contract. You said I'm doing no except, and you actually throwing. So no except is really good and actually can speed up your code. But if you're not using it correctly, you're actually going to create an issue. Let's say here's the thing. Let's say inside a no except function, you're calling a function that the compiler doesn't have a way to know if it's gonna throw or not gonna throw. For example, a standard C library that you're calling from no except. The compiler wouldn't know. So the compiler needs to add code to catch it, to catch that. Even though the compiler doesn't know that it's a C function and it doesn't throw. Now, more and more recent libraries that ships with your standard library C++ and your standard library C, they adding no except. So the compiler can say, oh, it's actually a no except C library, even though it's a C++, but there's some macros that they adding. I've seen that some time back. So things are being kind of better. So adding no except is definitely something that you should consider. By the way, measure if you have doubts. Take a look at the generated code. Swap, by the way, should be no except. A move constructor that I'll talk about in later slides should be no except as well. I think I'll stop here. We are 4 minutes before, but I have a couple things that are kind of tied together. Is there any question that people want to bring up? No? Okay. Hopefully you enjoy. Thank you for sticking all the way to the end. Hopefully you learned a couple of things or more. Have a good evening. Bye-bye.
Thank you, Kobe.
Thank you.
Thank you.
Thanks.
Thanks, Kobe.